All right, so we are going to try to write an equation that models this kind of growth, and we're kind of expressing this growth with these algebra tiles. It's a little bit weird because this first box has, this first arrangement has 8 boxes. This next one is a 4 by 5, so it has 20 boxes, and this last one is 6 by 6, so it has 36. Normally when we're doing these problems, there'll be a constant rate of change, so it'll be like plus 4, but if you watch here, it doesn't grow by a constant rate. We're going up by 12, and then we're going up by 14. So yeah, it's a little bit more complex than algebra tile patterns we've done in the past. So to start off this problem, I'm just going to nickname this our first arrangement, our second arrangement, and our third arrangement. And you may have noticed, we're going to try to create an equation where if I tell you what arrangement it is, you'll be able to tell me the number of tiles in that arrangement. So if I wanted to figure out how many tiles in here, I guess what I could do is I could just go count these, right? Like in this one, I go 1, 2, 3, 4, 5, 6, 7, 8. But that would take a really long time. There's a faster way to count rectangles, the area of them. It's base times height. Because if I know this is a 4 by 5, I can just multiply 4 by 5 to get 20. And so we're going to use this fact to help us write our equations. So the number of tiles is base times height. I'm just going to nickname the number of tiles y. And now I need to figure out a way to express our base and our height. And I'm just going to multiply those two things together. Right? And if I do that, I've got my equation. Okay, so let's start it off. Let's start with the base. So this base right here, I have a base of 2, this has a base of 4, and this has a base of 6. A good way to think about how we can write the base, because there's a little pattern between the number of arrangement is and how long it is. If I was looking at the, the 10th figure, right? Could you guess how long the base is? It may strike you that if you look at all the other ones, all they are is if you multiply it by 2, you'd get the base number. Right? So 2 times 10 is 20. Yeah, so if I multiply the arrangement by 2, yeah, I'll get that. If I multiply it by 2, I'll get that. If I multiply it by 2, I get that. In fact, any amount of whatever the arrangement is, x, if I multiply it by 2, that'll give me my base. And I'm just going to write instead of 2 times x, 2x. Right? So that's the base. Now what I want to figure out is how I can write the heights. Well, this has a height of 4, this has a height of 5, and this has a height of 6. So I can see that this is growing by 1 each time. Right? And if it's growing by 1, I know it's going to be something like 1x, right? Because that'll be how it's changing. But if you look closely, all I have to do to the arrangement number is I have to add it by 3. If I add 3 to it, I get 5. If I add 3 to it, I get 6. In fact, if you give me the 100th one, I bet you that the height of that is going to be 103. You can kind of see that pattern forming. So basically what we're doing is we're going to take whatever x value it is, right? Whatever x value it is, and we're just going to add 3 to it. And that'll be our base and our height. Now watch what happens with this equation. This is a totally fine equation, but I'm going to distribute this and make it clean up a little bit, make it look a little nicer. If these two things are multiplied together, I can distribute that 2x. And so another form of this equation is 2x squared plus 6x. Now it's always a good idea to kind of check these out. So this is my third excuse me. This is my third arrangement. So if I plug a 3 into this, I better get 36 out. So let's see how I do. If I plug the 3 into it, I get 2 times 3 squared plus 6 times 3. Substitute out both my x's for 3 because I'm looking at my third arrangement. So that's y equals 2 times 9 plus 18. So y equals 18 plus 18, and so y equals 36. And what do you know? We've got that. It'll work for every single arrangement there.